18 square meters. That is the total footprint we are talking about today. 3 meters wide, 6 meters long. A space smaller than most people's living room. Built upward into 2 full stories of completely livable, thoughtfully designed, honest-to-goodness home. No loft that you have to crawl into. No sleeping platform with 2 feet of headroom. 2 actual floors. 2 actual levels of usable space. And I'm going to walk you through exactly how it works. What it costs. What it gets right. What it gets brutally wrong if you don't plan it correctly. And whether a 2-story tiny home in a 3 by 6 meter footprint is actually a viable path to real, sustainable, full-time living. Or just the most impressive-looking bad idea on the internet. Stay with me until the very end of this video because the last thing I'm going to show you about this floor plan is the detail that most builders get completely wrong. And it's the detail that makes or breaks the entire concept. Before we go any further, if you are serious about tiny homes, small footprint builds, and honest alternative housing content, subscribe to this channel right now and hit the bell. We put out real information every single week with no fake numbers and no glossed over details. And leave a comment right now. Have you ever seriously considered a 2-story tiny home? Tell me what's drawing you to it or what's scaring you about it. I want to know exactly where you're at. Let's start with the math and the logic because understanding why 3 by 6 meters is a meaningful dimension helps you understand everything else about this build. 3 meters is approximately 9 feet 10 inches. 6 meters is approximately 19 feet 8 inches. If those numbers sound familiar to anyone who's spent time in the tiny house on wheels world, it's because a standard 20-foot trailer, the most common starting point for a towable tiny house, is remarkably close to this footprint. The 3 by 6 meter dimension has become a global reference point for micro-residential architecture because it represents the minimum dimension at which a full suite of residential functions, kitchen, bathroom, sleeping, living, can coexist in a single structure without one function completely cannibalizing another. At 2 stories, a 3 by 6 footprint gives you 36 square meters of floor area, approximately 388 square feet. That is meaningfully more livable than an 18 square meter single-story structure of the same footprint, and it achieves that additional space without consuming any additional land. The land footprint stays at 18 square meters. Everything gained comes from building upward. This vertical strategy is what makes the 2-story 3 by 6 concept compelling in an era of expensive land and increasing urban density. You are not buying or occupying more ground. You are using what you have more efficiently by going up instead of out. In cities where land costs are measured in thousands of dollars per square meter, a structure that doubles its usable floor area without doubling its land requirement is not just interesting architecture, it's a legitimate financial strategy. The 2-story 3 by 6 has been built in Japan, where micro-residential architecture has been refined over decades of urban land scarcity, in the Netherlands, in Scandinavia, in Australia, and increasingly in the United States as the ADU movement has created legal pathways for small secondary structures in residential backyards. It is not a theoretical concept. It is a proven residential typology, and it is one that most people in the English-speaking tiny house world have not fully understood or seriously considered. Let's talk about the dimension that will make or break your experience of this house before we talk about anything else. The 3-meter width. 3 meters. 9 feet 10 inches wall-to-wall. After you account for wall thickness, a standard wood frame wall is about 5 inches thick. Your interior clear dimension from finished wall surface to finished wall surface is approximately 8 feet 11 inches, or roughly 2.7 meters interior clear width. That number is livable, but it is not generous. And understanding exactly what it means spatially before you commit to this footprint is essential because 8 feet 11 inches of interior width imposes real constraints that affect every single design decision you make. A standard queen mattress is 60 inches wide, 5 feet. In an 8 foot 11 inch interior, a queen mattress leaves you with roughly 1 foot 11 inches on one side and a bit more on the other if you push the bed against one wall. That's tight. You can make it work, but you need to consciously design for it. Wall-mounted bedside lights instead of table lamps, recessed storage in the wall instead of a nightstand, a built-in shelf rather than a furniture piece. A standard kitchen counter depth is 24 inches. A standard kitchen galley, counters on both sides of a corridor, requires a minimum 36-inch clearance between the facing counters. 2 24-inch counters plus 36 inches of clearance is 84 inches, 7 feet. In an 8 foot 11 inch interior, a full galley kitchen takes up 7 feet of your interior width, leaving you with 23 inches on one end. That 23 inches is not wasted. It's where your refrigerator goes, recessed into the wall or built into the cabinetry. But it means the galley kitchen is the only kitchen layout that works in this width. There is no island. There is no peninsula. There is a galley, and it is efficient, and it works. But the decision is made for you by the dimension. A standard staircase width in residential construction is 36 inches minimum. In a 3-meter wide structure, the staircase is one of the most critical design decisions you will make, and we'll come back to it in detail later. But for now, understand that 36 inches of stair width in an 8-foot 11-inch interior means the stair eats 36 of those inches, leaving 71 inches, or 5 feet 11 inches, for everything that isn't the stair on that level. None of this is insurmountable. None of it means this footprint doesn't work. But it means that every single spatial decision in a 3x6 2-story home is a consequence of the width constraint, and designers and builders who don't understand this going in produce spaces that feel cramped and poorly resolved. Designers who understand it and design to it, who treat the 3-meter width as a creative constraint rather than a limitation to fight against, produce spaces that feel remarkably livable and intentional. The most important design decision in a 2-story 3x6 tiny home is how you divide the program between the 2 floors. This decision shapes everything: the stair location, the structural approach, the utility routing, the natural light strategy, and the daily experience of living in the space. There are 2 primary program division strategies, and they produce very different buildings. The first strategy is public downstairs, private upstairs. Ground floor contains the kitchen, the living area, and the bathroom. Upper floor contains the sleeping area and whatever secondary functions, a home office, a second sleeping space, a dressing area, fit within the remaining square meterage. This is the most common division strategy because it mirrors conventional residential logic and because it keeps the noisier, more active functions, cooking, entertaining, bathroom use, on the ground floor where they don't disturb sleeping. The second strategy is service downstairs, living upstairs. Ground floor contains the kitchen, bathroom, mechanical, and storage, all the functional service elements. Upper floor contains the primary living and sleeping space, which in this arrangement gets the best light, the best views, the most privacy, and the most precious square meterage. This strategy is more common in Japanese micro-residential architecture and in urban contexts where privacy and view are at a premium. It is less common in Western tiny house culture, but produces some of the most architecturally interesting small buildings. For a 3x6 footprint, the public down private up strategy is generally more livable for most people in most contexts, and it's the strategy we'll use as our primary reference throughout this video. But it's worth understanding that the second strategy exists and that for the right site, an elevated backyard position, an urban location with privacy concerns, a view worth capturing on the upper floor, it can be the better choice. In our primary strategy then, the ground floor of a 3x6 2-story contains the kitchen along one long wall in a galley configuration, a combined living and dining area in the remaining floor area, a bathroom tucked under the stair and the most efficient possible use of the space that the stair creates below its run, and the stair itself rising to the upper floor. The upper floor contains the bedroom, a small dressing or wardrobe area integrated into the floor plan, and whatever secondary function, desk, reading corner, yoga space, the occupant's life requires. Let's walk through each zone in detail. The kitchen in a 3x6 2-story occupies one long wall of the ground floor in a galley configuration running the full 6-meter length or portion of it. In a typical layout, the kitchen run is 3 to 3.5 meters long, roughly half the length of the floor, leaving the other half for living and dining. Within that 3 to 3.5 meter kitchen run, you can accommodate a full-size single basin sink, a 2 or 3 burner induction cooktop, an under-counter or full-height refrigerator, and base cabinet storage. Upper cabinets on the kitchen wall, or open shelving, provide additional storage without consuming floor area. The key kitchen design principle in this footprint is continuous counter. Every appliance, every function should be integrated into a single uninterrupted counter run with no gaps, no intrusions, and no wasted transitions between functions. The counter is the kitchen. Anything that breaks the counter, a standalone appliance sitting on the counter, a toaster that lives where a cutting board should be, degrades the functionality of the space disproportionately. In 2026, induction cooking has become the dominant choice for small footprint homes. Induction cooktops are faster than gas, more energy efficient, produce no combustion byproducts, and, critically for a tight space, can be built flush into the counter surface, functioning as counter when not in use. A 2-burner induction unit built into the counter runs $150 to $350 and is one of the highest value investments in a tiny kitchen. Ventilation is a design challenge in a 3-meter wide 2-story home that deserves explicit attention. Cooking vapors, steam, and odors in a small sealed space will make the upper floor uncomfortable and over time will damage finishes and promote moisture problems. A proper range hood, vented to the exterior, not recirculating, is non-negotiable. In a 3-meter wide building, the range hood vent run needs to be carefully coordinated with the wall structure and roof because it's occupying space that the structural design also needs. Plan the vent route before you design the wall, not after. The bathroom in a 3x6 2-story home is where the stair becomes your best friend and your biggest challenge simultaneously. The space underneath the stair run, what architects call the stair soffit, is dead space in most residential buildings. People put brooms there, or they build in a half bathroom, or they ignore it entirely with a coat closet. In a 3x6 2-story, that dead space under the stair is too precious to waste and the bathroom is its highest and best use. Under a standard stair run rising from ground to upper floor, a vertical rise of approximately 2.7 to 3 meters, which is the floor-to-floor height in a small 2-story building, you have a triangular volume of space that starts at about 2 meters of headroom at the base of the stair and tapers to 0 at the back where the last tread meets the upper floor. The usable portion of that triangular volume, the area with more than about 1.2 meters of headroom, is typically 2 to 2.5 square meters. A bathroom in 2 to 2.5 square meters sounds impossible, but a wet bath configuration, where the shower, toilet, and sink share a single waterproof space with a single drain, can be executed in as little as 1.8 square meters. The Japanese have been building functional wet baths in this footprint for decades. The design principles are clear: a wall-hung toilet rather than a floor-mounted one, which allows the floor to be fully tiled and eliminates the visual bulk of a pedestal. A compact wall-mounted sink or a fold-down sink that disappears when not in use. A handheld shower head on an adjustable rail. And full waterproofing of every surface, walls, floor, ceiling. Because in a wet bath, everything gets wet. The honest reality of a wet bath in this space. It works functionally, but it requires discipline in daily use. You shower, you dry, you use the space sequentially rather than simultaneously. For a single occupant or a couple with complementary schedules, it's completely manageable. For a family with simultaneous morning routines, it creates a bottleneck. Where the stair soffit doesn't accommodate the full bathroom, a small powder room, toilet and sink only, no shower, goes under the stair, and the shower is located elsewhere on the ground floor, either as a wet room at the end of the building or as an outdoor shower for warm climate builds. The remaining ground floor area after kitchen and bathroom, typically 8 to 10 square meters in a 3x6 layout, needs to serve as living room, dining room, and functional entry simultaneously. This multifunction requirement is where the fold-down, fold-out, and wall-mounted furniture philosophy becomes not an aesthetic choice but a structural necessity. A fixed sofa, a fixed dining table, and a fixed entry bench in 10 square meters will make the space feel like an obstacle course. Furniture that serves multiple functions and disappears when not in use is what makes the space work. The dining table in a 3x6 ground floor should be wall-mounted and fold down. When folded, it's a wall panel, a surface, not a piece of furniture occupying floor space. When deployed, it provides a full dining surface for 2 to 4 people, paired with stools that slide under the counter or hang on wall hooks when not in use. The dining function occupies 0 floor space except when it's actively being used. The living area furniture in a 3x6 ground floor should be low profile and light in visual weight. A low platform sofa rather than a traditional deep cushioned sofa, because the lower the furniture, the taller the room feels. A sofa that doubles as a guest sleeping surface when needed, eliminating the need for a dedicated guest room that this footprint cannot provide. Side tables that are actually stools, mobile, stackable, and usable as seating when additional guests arrive. The entry in a 3x6 home is not a room. It's a sequence. The door, a threshold, a place for shoes, a hook for keys and bags, and then immediately you are in the living space. Designing the threshold carefully, a flush or slightly recessed entry mat, a built-in bench at the door with shoe storage below and coat hooks above, makes the transition from outside to inside feel considered rather than abrupt. Natural light on the ground floor of a 3x6 two-story home is one of the most critical design variables. The two short ends of the building, the 3-meter facades, are where large glazing can go. Floor-to-ceiling glazing on one or both short facades brings light deep into the floor plan, prevents the long narrow space from feeling like a corridor, and creates a visual connection to the exterior that makes the space feel larger than it is. A skylight over the stair, if the structure and budget allow, brings light from above into the center of the building where the short-end windows can't reach. I want to spend real time on the stair because in a two-story 3x6 home, the staircase is not a circulation element. It is the central organizing element of the entire building, and every mistake made in stair design in a building this size has consequences that ripple through every other decision. In a 3-meter wide building, the stair can run in one of two configurations. It can run parallel to the long axis of the building, in which case it runs along one of the long walls, rising from ground floor to upper floor over a horizontal run of approximately 3 to 3.5 meters. Or it can run perpendicular to the long axis, which means it runs across the 3-meter width, taking up the full width of the building for the length of the stair run. The parallel configuration, stair along the long wall, is more space efficient because the area beside and below the stair remains usable on the ground floor. This is the configuration that places the bathroom under the stair. The disadvantage is that the stair intrudes into the long wall dimension of the building, which is where the kitchen typically wants to be. The stair and the kitchen have to coexist on the same long wall, which requires careful coordination of their positions and heights. The perpendicular configuration, stair across the width, is more dramatic and creates a cleaner floor plate on both levels because the stair is a distinct element crossing the building rather than a wall element running along it. The disadvantage is that it consumes the full 3-meter width for the length of the stair run, which in a 6-meter long building is a meaningful proportion of the total length. In 2026, the most successful two-story 3x6 designs use a hybrid approach, a stair that runs partially parallel and partially perpendicular, with a landing turn that makes the geometry work for both floors simultaneously. This is more complex to build but produces the most livable result in terms of both floor plate efficiency and stay experience. The stair also needs to carry storage. In a 3x6 two-story, every element that doesn't serve multiple functions is an element you can't afford. A stair with integrated storage, drawers in the treads, cabinets in the risers, shelving in the side panels, transforms a pure circulation element into the primary storage solution for the building. This is not a nice-to-have. In a 36 square meter two-story home, it is a necessity. Stair railing in a 3-meter wide space needs to be minimal and visually transparent. A cable railing, a glass panel railing, or a thin steel rod railing keeps the stair from visually sectioning the space. A traditional wood balustrade railing in a 3-meter wide space feels like a wall has been added across the building. It cuts the visual depth and makes both the stair and the room feel smaller. The upper floor of a 3x6 two-story home is where the investment of climbing the stair pays off. This is your private floor, the floor that visitors don't access, that the daily life of cooking and eating and working doesn't intrude on, that serves the restorative functions of sleeping and dressing and having space to yourself. In a 3x6 footprint, the upper floor has approximately 18 square meters of floor area, the full footprint of the building, before the stair opening takes its share. The stair opening, the hole in the upper floor through which the stair rises, typically consumes 2 to 3 square meters. So the usable upper floor is approximately 15 to 16 square meters. In 15 to 16 square meters, a well-designed upper floor can accommodate a queen bed, a built-in wardrobe along one wall, a small desk or reading area at one end, and, in some configurations, a second bathroom, particularly a simple shower room, if the ground floor bathroom is a wet bath that gets heavy use. The bed on the upper floor should be built-in, a platform with storage integrated below rather than a freestanding bed frame. A freestanding bed frame in 15 square meters is furniture that you walk around. A built-in platform bed in 15 square meters is part of the architecture. It defines the sleeping zone while the space around it remains clear and functional. Ceiling height on the upper floor of a two-story 3x6 home is one of the most critical decisions in the structural design. Many small two-story builds, particularly tiny houses on wheels attempting 2 stories, Make the mistake of compressing the upper floor ceiling height to get the total building height under road transport limits or planning restrictions. The result is an upper floor with 1.8 to 2 meters of ceiling height, which feels oppressive for anything beyond sleeping. For a 2-story 3x6 home on a permanent foundation, where transport limits don't apply, there is no reason to compress the upper floor ceiling height below 2.4 meters, which is the minimum that feels genuinely residential. The total building height with 2.7 meter ground floor clear height and 2.4 meter upper floor clear height, plus floor structure thickness between floors and roof structure, comes to approximately 6.5 to 7 meters. This is within the acceptable envelope for a residential structure in most jurisdictions, and it makes the upper floor feel like a room, not a crawl space. Natural light on the upper floor comes primarily from the short-end facades, one or both of the 3-meter gable ends. A large window or glazed sliding door at one end of the upper floor brings morning or afternoon light deep into the sleeping space. If you orient the glazed end toward the morning sun, you get a gentle natural alarm clock. If you orient it toward the evening sun, you get a golden hour reading room. This is a site-specific decision, and one worth thinking through carefully before you orient the building on the land. A Juliet balcony, a French door on the upper floor short facade with a railing but no projecting platform, costs very little structurally, brings significant light and ventilation to the upper floor, creates a visual and spatial connection between inside and outside at the bedroom level, and makes the exterior of the building look significantly more sophisticated than a flat wall with a window. It's one of the highest value architectural details in a 2-story tiny home. A 2-story structure in a 3-meter wide footprint has some specific structural considerations that a single-story tiny home does not, and understanding them helps you ask the right questions when you're working with a builder or an engineer. The most common structural approach for a 2-story 3x6 tiny home in 2026 is light wood frame, standard 2x6 stud walls at 16 inches on center, with a prefabricated floor truss or engineered I-joist system spanning the 3-meter width between the 2 long walls for the upper floor structure. This is conventional residential construction at a small scale, and it's the approach that the widest range of builders, engineers, and building departments understand and can permit. The 3-meter span between long walls is entirely manageable with standard engineered floor joists. You can span 3 meters with a 9.5-inch or 11.7-inch LVL joist at typical residential floor live loads with good deflection performance. The floor structure between the 2 levels also serves as the acoustic separator between ground floor and upper floor. And in a small 2-story home, acoustic separation between the levels matters more than in a large house because sound travels more efficiently through a compact structure. A heavier floor assembly, with resilient channel, mass-loaded vinyl, or mineral wool between joists, significantly improves the acoustic performance of the upper floor. Budget $1,500 to $3,000 for acoustic treatment in the floor assembly if sound isolation between floors matters to you. An alternative structural approach that has gained traction in 2026 for small 2-story builds is cross-laminated timber, CLT. CLT panels can serve as both wall structure and floor structure simultaneously, eliminating the need for a separate stud wall and floor joist system. CLT construction is faster, produces a higher quality acoustic and thermal performance, and creates an aesthetic of exposed wood on walls and ceiling that many people find more appealing than painted drywall over stud framing. The cost premium over conventional light frame in 2026 is approximately 15% to 25% for the structural package, and CLT availability varies by region. It's more readily sourced in the Pacific Northwest and Northeast where the timber industry has invested in CLT production. If CLT is accessible in your market and you value the aesthetic and performance benefits, it's worth serious consideration for a small 2-story build. Steel frame construction, either light gauge steel stud or heavier structural steel, is less common for tiny residential builds but becomes relevant when the structure needs to be shipped in a container for international delivery, when it's being placed on a challenging site that requires maximum structural rigidity, or when the owner has a specific industrial aesthetic in mind. Steel frame adds cost, typically 20% to 30% over wood frame for the structural package, and requires different thermal detailing because steel conducts temperature efficiently and can create condensation problems at the wall-roof junction if not properly thermally broken. Mechanical systems in a 3x6 2-story home require more careful coordination than in a larger building because the ductwork, pipe runs, and equipment all have to fit into the same constrained envelope that the architectural and structural elements are competing for. Heating and cooling in a 3x6 two-story is most efficiently handled with a multi-zone mini-split system. One head unit on the ground floor covering the kitchen and living area. One head unit on the upper floor covering the bedroom. The two zones allow independent temperature control between floors, which matters because heat rises. A ground floor that's comfortable in winter can produce an upper floor that's too warm, and a single-zone system doesn't let you manage this. The mini-split condenser unit, the exterior component, mounts on an exterior wall bracket and needs to be positioned where it has adequate airflow and where the refrigerant lines can run efficiently to both interior heads. On a 3-meter wide building, the condenser location needs to be coordinated with the architectural design of the exterior to avoid it dominating a primary facade. Mounting it on the rear exterior wall, the back of the building away from the primary street or garden view, is the cleanest solution. Plumbing in a 2-story home requires a vertical stack, a drain line that runs vertically through the building, typically in the wall cavity of the bathroom wall, to connect the upper floor plumbing if there's a second bathroom upstairs to the ground floor drain system. The location of the vertical stack is a design constraint that gets established early and doesn't move easily once walls are framed. In a 3x6 building, the plumbing stack is typically located in the interior wall that separates the bathroom from the living area, and it needs to be coordinated with the stair location and the upper floor plan simultaneously. Electrical in a 2-story 3x6 home runs on a standard 100 amp service for a single occupant or couple with typical residential loads, or 200 amp if the occupant is running significant home office equipment, an EV charger, or large electrical appliances. The panel location on the ground floor, typically in the kitchen or utility area, needs to be accessible for future service while not consuming prime floor space. A recessed panel box with a flush cover, integrated into the kitchen cabinetry, takes up zero visual or floor space while remaining fully accessible. Let's talk money. Because the 3x6 2-story tiny home has been aestheticized on social media to the point where the actual cost is almost never discussed honestly, and people pursuing this path need real numbers. A site-built 2-story 3x6 tiny home on a permanent foundation in 2026, fully finished, mid-range materials, in a moderate-cost market in the United States, costs approximately $95,000 to $160,000 for the build itself, not including land and site prep. Breaking that down, foundation for an 18 square meter footprint, a concrete slab with thickened edges and proper drainage, runs $8,000 to $14,000. Structural framing, including both floors and the roof, runs $18,000 to $28,000 with labor. Exterior cladding, windows, and roofing run $14,000 to $22,000. And on a building this small, the ratio of exterior surface to floor area is high, which means cladding and window costs as a percentage of total build are higher than on a larger building. Insulation, spray foam or combination of rigid foam and bat, runs $5,000 to $9,000. Electrical runs $10,000 to $15,000. Plumbing runs $7,000 to $12,000. Vac, 2-zone mini-split, runs $6,000 to $10,000. Interior finishes, drywall, flooring, kitchen, bathroom, stairs, doors, paint, run $22,000 to $40,000. The stair itself, if it's a custom storage integrated build, runs $2,500 to $6,000. And permits, engineering, and professional fees run $4,000 to $8,000. In a high-cost market, California, New York, coastal New England, at 30% to 50% across every labor line item. In a lower-cost market, rural South, Midwest, Mountain West away from resort towns, these numbers can come down 15% to 25%. Prefabricated and modular versions of the 2-story 3x6 concept are beginning to appear in the market in 2026, particularly from European manufacturers who have been building this typology longer. A factory-built 2-story 3x6 module from a European manufacturer, shipped, delivered, and craned onto a prepared foundation, runs $80,000 to $130,000 not including shipping, foundation, or site work. Shipping from Europe adds $8,000 to $18,000 depending on origin. Foundation and site work adds $15,000 to $30,000. Total with European prefab, $103,000 to $178,000. The advantage is speed and quality control. The disadvantage is the complexity of international shipping and the fact that utility systems designed for European standards need to be adapted for North American electrical and plumbing codes. Let's be completely honest about this, because the 3x6 two-story tiny home is genuinely the right solution for a specific type of person and genuinely the wrong solution for others. It is right for a single person or couple without children who want a permanent ownership track home with a small land footprint. The two-story configuration gives a couple genuine spatial separation. One person can be in the kitchen and living area while the other has the entire upper floor as a private retreat, which is something that a single-story tiny home of the same square meterage cannot provide. That spatial separation is undervalued and underappreciated until you're living with another person in 388 square feet, and you understand viscerally why it matters. It is right for an urban or suburban infill context where land is expensive and a small footprint has a large financial advantage. A 3x6 footprint can fit in backyards, urban lots, and side yards where a larger structure cannot. As an ADU on an existing residential property, it maximizes the livable area achievable in the minimum land footprint. It is right for someone who thinks architecturally, who finds the constraint of the footprint exciting rather than frustrating, who enjoys the design puzzle of making a small space work exceptionally well, and who will invest the time and thought into the details that make a 3x6 two-story feel like a home rather than an exercise in spatial compression. It is wrong for families with children. A two-story 3x6 home has no privacy for multiple children, no space for the chaos and equipment that children require, and a stair that is genuinely hazardous for young children regardless of how well it's designed. The square meterage per person math simply does not work for a family in this footprint. It is wrong for someone who frequently entertains large groups. The ground floor living area of a 3x6 home maxes out comfortably at 4 people seated for dinner, and the spatial dynamic of hosting in an 18 square meter ground floor is something you adapt to or you don't. Some people find the intimacy of a tiny dining space convivial. Others find it stressful. Know which one you are before you build. And it is wrong for someone who works from home in a job that requires significant dedicated workspace, multiple monitors, physical files, a professional backdrop for video calls, space for equipment or materials. The upper floor desk area in a 3x6 two-story is a genuine workspace for focused solo work. It is not a home office that separates professional life from domestic life in any meaningful spatial way. I promised you at the beginning that I'd tell you the detail most builders get wrong in a two-story 3x6 home. Here it is. The transition at the top of the stair. When you reach the top of the stair and step onto the upper floor of a 3x6 two-story, what you experience in those first 2 seconds, the ceiling height at the stair head, the view that opens up, the sense of arrival on the private floor, determines whether the whole building feels generous or whether it feels like you've been compressed into a tight box. Most builders in a small 2-story building compress the ceiling height at the stair head to save structural depth, or they run the upper floor structure right to the stair opening without any consideration for how the person arriving at the top of the stair experiences the space. The result is that you arrive at the top of the stair crouching slightly, with the ceiling close over your head, and the experience of the upper floor is diminished from the first moment you enter it. The buildings that feel remarkable at this scale do the opposite. They use a vaulted ceiling on the upper floor, following the roofline rather than a flat ceiling, so that as you arrive at the top of the stair, the ceiling is high over your head and the space opens upward and outward. They locate the stairs so that you arrive facing the primary window, so the first thing you see at the top of the stair is light and view, not a wall. And they create a moment of threshold at the stair head, a step, a change in material underfoot, a slight widening of the floor, that tells your body you have arrived somewhere distinct and considered. This detail costs almost nothing extra if it's designed in from the beginning. And it is the difference between a tiny home that feels like an achievement and one that feels like a compromise. 18 square meters. 36 square meters of livable space on 2 floors. A kitchen that works, a bathroom that functions, a living area that breathes, a sleeping floor that gives you privacy and quiet, and a window facing something worth looking at. The 2-story 3x6 tiny home is not for everyone. But for the right person, on the right piece of land, with the right design invested in it, it is one of the most architecturally interesting, financially efficient, and genuinely livable small residential footprints available in 2026. It asks more of you as a designer and as a daily inhabitant than a larger home does, and it gives back more than you expect. If this video gave you something real, a clearer picture of what this footprint actually involves. The honest costs, the honest constraints, the details that matter. Please hit the like button right now. It takes 2 seconds, and it is how this content reaches more people who are thinking seriously about building small and building well. Subscribe for more honest tiny home, condominium, and small footprint build content every week. Share this with someone who's been talking about a 2-story tiny home and doesn't have the full picture yet. And leave a comment below. After everything we just walked through, are you more drawn to this concept or less? What's the detail that surprised you most? What question do I need to answer in a follow-up video? I'll be in the comments for the next hour. Let's talk about it. See you in the next one.